Hello, lovely viewers. You are welcome back to Easy Mathematics. We thank God for another opportunity. Please, today we are coming to look at the final aspect in set. Before we begin, I would like to say don't forget to hit the subscription button, share for others to also benefit from today's presentation. Today we want to look at rationalizing sets. We began with the introduction of sets, introducing sets, and we move on to a different topic. Today we want to look at rationalizing sets, how to rationalize sets. Now we say that rationalization or rationalizing sets, Now this is the process of making the denominator of a fractional set whole. Okay, so an example, this is a fractional set, 1 over set 3. Now with this fractional set, we have to rationalize it. Okay, now to rationalize it simply means we are going to find the possible ways and means to let the denominator be a whole number or a rational number. Okay, we don't want the denominator to have a set. So if the denominator is having a set and we need to get rid of the set, we rationalize the fractional set. Now before we can rationalize a fractional set, we need to know certain things. Okay, we have two different things we have to note. Now number one, to rationalize sets, we multiply both the numerator and the denominator by the denominator. That is the first thing you have to know. So if you take this example, okay, and I want to rationalize this set. To rationalize this set, I am going to multiply the numerator and the denominator by the denominator. And what is the denominator? The denominator is set 3. So if I want to rationalize this fraction or this rational fraction, then I will multiply the numerator by set 3 and multiply the denominator also by set 3. Do the multiplication, then you will be able to rationalize the fractional set. Now, in some situations, we cannot just use the denominator to multiply both numerators. An example is this very one. You have 1 over 4 minus set 3. Now, because the denominator is having set 3, we have to rationalize the fractional set. Okay, so with this type of fractional set, we cannot multiply the numerator and the denominator by the denominator. This is because we are going to get a final answer for the denominator to be 0, which will make our solution undefined or math error. So when you have a fractional set of this nature, whereby the denominator is 2 terms, that is, you have a plus b, or the set a plus the set b, or the set a minus the set b as the denominator, then we need to do something to get rid of the what? Of the denominator having the set. Now to do this, it says that when the denominator is in the form set a plus set b, or if it is in the form set a minus set b, then we are going to multiply both the numerator and the denominator by the conjugate set. Now it has been underlined, and the question is, what is a conjugate set? Now simply put, a conjugate set is the opposite sign or the opposite of the denominator based on the sign. Okay, we are basing on the what? On the sign. That is the conjugate set. So if you take this example, for instance, what is the denominator? The denominator is 4 minus set 5. So if I want to rationalize this set, I will multiply the numerator by the conjugate set of the denominator. And what is the conjugate set? Now if you have 4 minus set 5, the conjugate of 4 minus set 5 is 4 plus set 5. That's the conjugate what? Set. So the same thing if I am having set 2 plus set 3. To find the conjugate set is going to be what? Set 2 minus set 3. So the conjugate of 4 minus set 5 is 4 plus set 5. So we will use this conjugate to multiply the numerator. Then we use this same conjugate to multiply the denominator. Now with the help of being able to multiply, we will get rid of the what? Of the set at the denominator. And that is what we call rationalizing or rationalization of sets. So we will take an example, then we will follow the procedures given in terms of rationalizing sets. In terms of rationalizing sets. Now let's look at the first one. It says that rationalize the following. Okay, we are rationalizing the following. And we have number 1. So let's take number 1. Number 1, you have 2 over set 3. You have 2 over set 3. Now with this type of fractional set, how do we rationalize it? We have been told that to rationalize it, multiply both the numerator and the denominator by the denominator. So with this type of fractional set, if we are going to rationalize this set, then we are going to multiply the numerator and the denominator by the denominator. And what is the denominator? The denominator is set 3. So we are going to multiply the numerator by set 3. Then we also multiply the denominator by set 3. Okay? This type of fractional set, this is how we rationalize. Multiply the numerator and the denominator by the denominator. So if the denominator is set 5, do justice to that. But the denominator is set 3, not 3, but rather set 3. So now we will be having 2 times set 3. When we're looking at simplification of sets, we said that a number times a set is the number set. So 2 times set 3 is 2 set 3, which is all over. Then you have set 3 times set 3. Set 3 times set 3. What are you going to get? We are going to get set 3 squared. Why is it 3 squared? Because 3 times 3 is 3 squared. Okay, so what do we do? The square will now cancel the root, the square root. Now what do we have as our final answer? Now the rationalized form will give you 2 set 3 all over what? 3. And so now you can see that the denominator is now a whole number. Okay, now this shows that we have rationalized the set. Let's briefly go over it again. When we have this type of set to rationalize, where you have 2 over set 3, and you are rationalizing this set. To rationalize this, you multiply both the numerator and the denominator by the denominator. So the denominator here is what? Is set 3. The denominator is set 3. So we multiply the numerator by set 3, which is 2 times set 3, which will give you 2 set 3. Then you multiply the denominator by the denominator. That is the denominator times itself. Now when the denominator multiplies itself, you are having the square root of 3 squared, because 3 times 3 can be written as 3 to the power 2. Now because there is a square root here and we have a square, they will cancel out. Then you have 2 set 3 over 3. Now we have been able to rationalize the set, and we have the denominator to be a what? A whole number. So we said that this is the process of making the denominator of a fractional set whole. So once we have been able to make the denominator of this fractional set a whole, we have what? Rationalized the set. As simple as that for the first one. For the first one. So anytime we have this type of fractional sets, we just multiply both numerators, both the numerator and the denominator by the denominator. then we are being able to rationalize. Number 2, let's look at the type of the number 2. Number 2, we have to rationalize 2 over 1 plus set 2. So this is a fractional set. We have to rationalize it because of the denominator having a square root. Because of the denominator having a square root. So what do? We have 2 over 1 plus set 2. This is what we have. Now the question, when we began, we were told that if the denominator is of this form, okay, so this form, just like this, or you have a plus set b, if you have the denominator to be of this form, you do not multiply the numerator and the denominator by the denominator. No. When you do that for this, you will not get a whole number. Since we have a positive, you will not get a whole number. So since you will not get a whole number, we will therefore multiply the numerator and the denominator by the conjugate set of the denominator. Now with the denominator, you have 1 plus set 2. 1 plus set 2. What is the conjugate set? The conjugate set is 1 minus set 2. What changes is the sign. So I will say that the opposite sign of the what? Denominator. You multiply the numerator and the denominator by the denominator as the opposite what? Sign. So if it is positive, you just change it to what? Negative. If it is negative, you just change it to what? Positive. That is the conjugate what? Set. So if the rational set is of this form and the denominator is having 2 terms, whereby there is a set in one term, we multiply the numerator and the denominator by the conjugate set. So this becomes times 1 minus set 2 all over 1 minus set 2. So this is the denominator. The denominator is 1 plus set 2. But its conjugate set is 1 minus set 2. So we multiply the numerator and the denominator by the conjugate set, which is this. Now when we get to this place, we'll just take our time and multiply. But we are going to apply the idea of algebraic expression here. That is multiplying 2 binomials or multiplying involving brackets. Multiplication involving brackets. We will apply it here. We shouldn't take it in a rush. Let's take our time here. Now 2 times 1 minus set 2 can be written as 2 brackets of 1 minus set 2 all over. This also can be written as 1 plus set 2 in one bracket, then the bracket of 1 minus set 2 in another bracket. So in algebra, multiplication of algebraic expression, we have this to be the what? The distributive property, whereby the 2 multiplies each of the elements in the bracket. Then when you also have something like this, a bracket multiplying a bracket, that is 2 binomials, we were told that the first element in the first bracket multiplies everything in the second bracket. So 1 will multiply everything here. Then set 2 will also multiply everything here. With that idea, we can rationalize the set. So let's take it one after the other. So with the numerator, we are going to have 2, because 2 times 1 is 2, minus 2 times set 2, which will give you 2 set 2, all over. Then now 1 will multiply the second bracket, which is 1 minus set 2, then plus set 2 will also multiply 1 minus set 2. So it is just like you doing what? Expanding the bracket. We take our time to solve it because it is new to us. Now with the numerator, we are done with the numerator. So we are concentrating on the denominator. Now the 1 is going to multiply 1. 1 will multiply this. Then set 2 will multiply this. Then set 2 will also multiply this. We shouldn't be in a rush. Let's take our time. So with the numerator, we have 2 minus 2 set 2 all over 1 times 1 is 1. Now 1 times negative set 2 is negative set 2. Then we are now going to set 2 times 1 will give you plus set 2. Then you have set 2 times negative set 2. It will give you set 2 squared, which is the same as negative 2. What is the same as what? Negative 2. Now what can we say here? We have negative set 2 plus set 2. Negative set 2 and plus set 2 will cross out. So we now have 1 minus 2. So this will give you 2 minus 2 set 2 all over 1 minus 2 is negative 1. So we are now having negative bracket of 2 minus 2 set 2. So we have it like that. Sorry. So we just bring the sign in front of it. So we are now going to get negative 2 plus 2 set 2 as our answer. Straightforward with that. Now how do we get that? You know that the negative affects everything there. So since this is positive, it gives you negative 2. And since this is negative, it gives you positive. And so you have negative 2 plus 2 set 2 as the answer. So all you should know is that when it comes to rationalizing sets, if the denominator is of this form, then you multiply the numerator and the denominator by the conjugate set. By the conjugate set. So here, the conjugate set is 1 minus set 2. So we use the conjugate set to multiply the numerator, and we will use the conjugate set again to multiply the denominator. So when 2 multiplies this, you have 2 times 1, 2, and 2 times this is negative 2 set 2. When you multiply the denominators, we are going to have 1 multiplying 1 minus set 2, then set 2 multiplying 1 minus set 2. When 1 multiplies, we have 1. And 1 times negative set 2 is negative set 2. Set 2 times 1 is set 2. And set 2 times negative set 2 is negative 2. But when we have 1 minus 2, 1 minus 2 is what? Is negative 1. 1 minus 2 is negative 1, which results to this. Okay? Now, the negative will affect everything here. So, if the negative affects everything there, then we are going to have this to be negative 2, then we have this to be positive 2 set 2. We can choose to leave our answer here, or we can choose to bring the positive set first, then we have minus 2. So we can have 2 set 2 minus 2. We are also correct to write it like that. Let's look at the last one. If we are able to complete, fine. If we don't, you complete and you drop your answers. Now you have 2 plus set 3 all over set 3 minus 1. So the denominator, okay, look at the denominator. There is a set. So this is a fractional set, okay. We don't want the denominator to have a set. So we want it to be a whole number or a rational number. So what do I need? I am not going to multiply the numerator and the denominator by the denominator. No, only when it is of this nature, that is why we are going to do that. But because the numerator is of this format, it is of this format, what do? We will rather multiply the numerator and the denominator by the conjugate set of the denominator. What is the conjugate set? This is set 3 minus 1. So the conjugate set is going to be what? Set 3 plus 1. So we will multiply this by set 3 plus 1. Then we also multiply the denominator by set 3 plus 1. So this is the conjugate word set. All you change is the sign. So if it is negative, you change the sign to positive, then you multiply. If it is positive, you change to negative, then you multiply. The same idea we did for the first one is the same thing we are going to apply. So this is multiplying this, and this is also multiplying this. So to arrange it, we are going to say 2 plus set 3 in a bracket. Then we have another bracket, set 3 plus 1, also in a bracket. All over, set 3 minus 1 in a bracket. Then we have set 3 plus 1 in a bracket. So now you have two binomials, whereby you are multiplying two what? Brackets. So this will multiply everything. This will multiply everything. Now this and this, they are different. Because when you look at the numerator here, you have 2, which just multiply the conjugate set. But with this one, you have 2 terms multiplying by the conjugate set. So we have to be extra careful when we have a fractional set of this nature. We have to be extra careful. So now, let's take our time and go again. So 2 will multiply everything. So we have 2 brackets of set 3 plus 1. Remember, 2 will multiply the second bracket. Then set 3, which is plus set 3, will also multiply set 3 plus 1. All over. Again, you have the same thing. The first element in the first bracket will multiply everything in the second bracket. So we have set 3 multiplies set 3 plus 1. Then you have minus 1. So minus 1 bracket of set 3 plus 1. So let's take it step by step. From the numerator, you have 2 times set 3. 2 times set 3 will give you 2 set 3. 2 times 1 will give you plus 2. Then you have set 3 times set 3 will give you plus 3. Then set 3 times 1 will give you plus 1 set 3. But the one, as we said in our previous lesson, is not written. So we've expanded the bracket here. 2 times set 3 is 2 set 3. 2 times 1 is 2. Now set 3 times set 3 is what? Is 3. And set 3 times 1 is set 3. So we've dealt with the what? The numerator. Now let's deal with the denominator and see. In the denominator, we are going to do something. So we have set 3 times set 3, which will give you 3. Set 3 times 1 will give you 1 set 3, which the 1 is not written. Now you have minus 1 times set 3 will give you minus set 3. Then minus 1 times 1 will give you negative 1. Now look at the numerator, look at the denominator. If looking at both will confuse you, fix your eyes only on the numerator. So let's finish with the numerator, then we look at the denominator. Now if you come to the numerator, you can say that we can group like terms here, because we have 2 set 3, set 3. 2 and what? 3. So we can even choose to just add from here. 2 plus 1 is 3. Because they have the same sets, we can add. So this will give you 3 set 3 plus of what? 5. All over. Now we fix our eyes on the what? The denominator. On the denominator. So now you have set 3 minus set 3. Just like you say, what is 5 minus 5? Which is 0. So what do we say? Sorry, we say that both will cancel out, or will cross out both sets. Now when you cross out, what do you have? You have 3 minus 1. 3. If you take away 1, what do we have? We have 2. So now you see that the denominator was said, and now we have rationalized, and the denominator is what? It's a whole number. So therefore, our final answer, we can say 5 plus 3 sec 3 all over what? 2. And you leave it there. Mostly when we solve, we bring the whole number first, and we take the set after the whole number is written. So now that we've been able to rationalize, you see that we don't have the denominator to be a what? A set. We should know that this is a new topic which has been added to the curriculum or to our topics in this curriculum. And it is likely for us to come across a question like this in our end or our final exam, that is our BEC or the standardized test. It is very possible that we may come across, either it could be a sub question, either it could be a major question. All you need to do is understand the sets, get the concept of it, try more examples, get past questions. Of course, you don't have past questions on this, but try more examples on this, because your mocks that you've been writing, you may come across this which should bring something to you that there will be a question from set automatically this year, because it is something new that has been added. So we have looked at how to rationalize sets. Please, you can drop comments. If you have any suggestion, drop it. And don't forget that you have to share, like the page, and also sponsor the program so that we can get enriched far with more topics. We will continue next time, but this time when we come again, we will look at binary operation, because a colleague who responded to our last video, a question we dropped, has been able to come out with a solution, and we applaud for that. We are very grateful for your concern. That means we are doing something to your interest. Don't forget to subscribe. We will meet again and we will look at binary operation. Very interesting topic. See you next time. Bye bye.